Theoretical recap. File permissions in Linux are a foundational security mechanism. Every file and directory has three permission sets: owner, U, group, G, and others, O. Each set can carry three types of permissions: read, R, write, W, and execute, X. The chmod command modifies these permissions, and its symbolic mode uses a human-readable syntax, who operator permissions. The who part is U, G, O, or A, all. The operator is plus, add, remove, or equals, set exactly. For example, chmod G plus W file.txt adds write permission to the group, while chmod ORX script.sh removes read and execute from others. A common mental model. Think of permissions as a security gate. The owner controls their own gate, the group shares a second gate, and others face a third. Chmod is the key maker. Common mistakes include confusing you, user/owner, with a, all, forgetting that directories need execute permission to be entered, and inadvertently opening permissions to others when using chmod a plus. Remember, in a security context, the principle of least privilege means granting only the minimum permissions necessary. Never add permissions just in case. Also note that chmod does not change ownership, that is chown's job, which you will encounter separately. Mini example. To make a script executable by its owner only, chmod u plus x, go x deploy.sh, this adds execute for the owner and explicitly removes it for group and others in a single command. Workshop brief. This workshop directly follows your study of permissions and ownership, introduction, and builds on everything you have practiced so far: navigating the file system, manipulating files, and understanding the Linux hierarchy. Your goal here is to move from passive knowledge to active mastery of symbolic chmod by working through a realistic, security-oriented scenario. You will set up a controlled environment, apply targeted permission changes using symbolic syntax, diagnose problems, and reflect on the security implications of each decision you make. You have 3 hours to complete this workshop and must submit your solution before the deadline expires. This duration is deliberately tight enough to keep you focused but generous enough to allow careful thinking and documentation. Do not wait until the last moment to start. Scenario. Imagine you are a junior DevSecOps engineer onboarding onto a small Linux server used for a web application deployment pipeline. A previous administrator left the server in a messy permission state. Several files and directories have incorrect permissions that could expose sensitive data or allow unauthorized script execution. Your mission is to audit and remediate these permissions using only symbolic chmod, document every change you make, and justify each decision from a security standpoint. Steps to follow. Start by creating a dedicated working directory called permissions_lab in your home directory. Inside it, reproduce the following structure: a directory called script/containing two files, deploy.sh and rollback.sh, a directory called config/containing two files, app.conference and db.conference, and a directory called log/containing one file, access.log. Use touch and macdir as you have practiced. Then, deliberately set broken permissions on these files using chmod to simulate the messy state left by the previous admin. For example, make config files world readable and scripts executable by everyone. Once your environment is set up, perform a full audit using LSL and tree, as covered in your Explore with Tree activity, to document the initial state. Save this output to a file called audit_before.txt. This is your baseline. Now apply the correct symbolic chmod commands to reach the following security targets. Deploy.sh and rollback.sh should be executable only by the owner, not readable or executable by group or others. App.conference and db.conference should be readable and writable by the owner only, with no permissions for group or others. Access.log should be readable by the owner and group, but not writable or executable by anyone except the owner, and completely inaccessible to others. The script/ and config/ directories should be accessible, enter plus list, only by the owner. The log/ directory should be accessible by owner and group but not by others. After applying all changes, run another LSL and tree audit and save the output to audit_after.txt. Compare the two files and write a short file called justifications.txt, plain text, no special format required, where you explain, for each file and directory, why the permissions you set are appropriate from a security perspective. Reference the principle of least privilege explicitly at least once. Finally, introduce one deliberate mistake, add a permission that should not be there, and then fix it using the equals operator, exact assignment, rather than plus or. Document this in justifications.txt as a separate section called operator comparison and explain the difference in behavior between equals, plus, and, in symbolic chmod. Advice and guidance. If you get confused about the current state of a file's permissions, LSL is your best friend. Rerun it after every chmod command until the workflow becomes natural. If a chmod command does not seem to produce the expected result, check that you are targeting the correct path and that you have ownership of the file. Remember, you cannot chmod a file you do not own unless you are root. Pay close attention to directory execute permissions. Forgetting X on a directory is one of the most common traps beginners fall into. When writing your justifications, think like an attacker. Ask yourself what damage could be done if each file had overly permissive settings. This reflective habit is central to the security mindset you are building throughout this course.